Okay, so let's talk about this. So we have Joe is selling his hog at the fair for $2 a pound, plus an additional $30 for a fair service charge. So let's create an equation that represents a situation where X is the number of pounds the hog is, and Y is the cost. So where do we start for this? What do we do? Thinking back to before fair. So you said you were...
I have it, but I don't know if you have to say it on the video.
What do you do? Or what do you write down? Let's start with that.
Y equals 2x plus 30.
Y equals 2x plus 30. Okay, so if we always remember our equation for a linear equation like this was y equals mx plus b. We had our output, we had our slope, our input, and our y-intercept. So if we remember, our y-intercept was always our starting amount, or always our starting value. If we weren't putting anything into something, where would we start at? So if this hog was 0 pounds, but you were still buying it anyways, for whatever reason, how much would you be paying? $30. There was that initial $30 as like that fair service charge. So that's our y-intercept. Along with that, we had how much we were increasing by, how much we were increasing by every pound. How much was the cost per pound? $2. So that was our slope. If we had cost, or if it was 1 pound, it cost $2. Or $2. If it was 2 pounds, it cost $3. 4 pounds, so on and so forth. I said 2 pounds with $3. That's not right. $4. But it's increasing by 2 every time. And so that would be our slope. So it's our output equals 2x plus 30. Are we okay with this? We sort of remember a little bit before? And we'll be working again with equations, not as much today, but we'll have time to review this. If you want to sit down with me at some point and talk about this, or say you didn't do as good on your test as you wanted to and you want to review this, go for periods a good time, or if you have a study hall at some point, let me know, and we can talk about this. But this was just a quick review of what we talked about before. But today, we're going to do a little activity to get you moving around. I know you just got back to school, so you've been tired of sitting in your chair all day. So we're going to do a quick activity to get us moving around. All right, so on this game, I'm going to have 4 options for you. You need to figure out which category you fall into, and then you need to find your location to stand. So if your birthday is from January to March, if you fall in that range, you need to stand by the door. If your birthday is in April to June, you need to stay seated. If your birthday is July to September, you need to stand by your chair. And if your birthday is December through October, or October through December, you need to stand in the back of the room. Okay. So we have a lot of January through March birthdays, apparently. We also have a lot of July through September birthdays, it seems like. Only 3 April through Junes, and only 3 October through Decembers. Okay, good. Round 2. If you walk to school, stand by the door. If you rode in a car, stay seated. If you rode the bus, stand by your chair. If you rode your bike, stand in the back of the room. Okay, we had a couple people walk. Most people rode in some car of some sort. Only a couple of you rode the bus. So. And then no one rode their bike today, which was pretty ugly this morning, I understand. What? You don't know if you have the bike, or you don't have a bike? Bikes are nice. Alright, last round. So if you're younger than 13, stand by the door. If you are 13, stay seated. If you're 14, stand by your chair. And if you're younger than 17, stand in the back of the room.
Everybody's younger than Mark. What? No.
It isn't specific. Loophole.
Okay.
No, I'm 20.
So we don't have any 13-year-olds, which is probably good because we're all freshmen. Or younger than 13, that'd be.
Not concerning.
So what's the issue with the last two?
Everybody's younger than 17. Lots of people.
So a lot of you are 14, but then some of you are also, or everyone is also younger than 17.
You don't need to make up your mind.
Okay. All right, have a seat. Go back to your original seat. Without destroying the classroom, please.
I know.
So, with that activity, what was different about the third one compared to the other two?
Loophole. Yeah, loophole.
What do you mean?
Because
It wasn't such a small case.
So why didn't everyone stand back there? Use what? There was other instructions, like what? What was that, Toby?
The instructions that came before.
Okay, which were?
Your immersion.
Okay, so some people were conflicted, because some people were 14, so they were told to stand by their chair, but they're also younger than 17, so they're told to stand in the back of the room. So which one did they go to?
That's why I'm so. You could take your.
I didn't brought a chair back.
No.
Just let them.
Okay. So this was sort of a little intro activity, and we'll discuss why. But today we're going to talk about something in math that we call functions. So we have these special relationships in math that are called functions. Have you heard this word before in previous? Yes? You should have. So you may have, you may not. I don't know exactly if it's a word used very much in AP math, but we're going to use it all the time in Algebra 1. So this is like a really important word. This is like your number one thing if you're going to get anything for today, to understand this word. So what a function is a special type of relationship. And what this relationship needs to do in order to be a function, for every input, there needs to be one specific output. Forgot my U. So in order to be a function, for every input into whatever this function is, functions can be all different kinds of things. For every input, there needs to be one specific output. So on that first example, everyone had their birthday, which was the input. Everyone had a specific output they were told to go to. If you were January through March, you were told to go by the door. If you were April through June, you were told to stay seated. Everyone knew where they were supposed to go. Same with the second one. There's only 4 possible ways of getting to school unless you took some airplane that I didn't know about. So everyone had an input, and they were all told a specific spot to go to. The last one, though, some of you fell under 2 of those categories. Those inputs, of those of you who are 14, had 2 different possibilities. You were told to go either stand by your chair or you were told to go to the back of the room. There was 2 outputs. So this would be an example of not a function. Because some of you didn't know exactly where to go. You were supposed to go to 2 different places, but you can't. So a function, for every input, there's only one specific output. Are we okay with that definition for the moment? And we'll see examples of functions and how they sort of relate. So another example, Every student will receive 1 grade on your Friday assessment. It's going to be out of so many points, and it's going to be 1 specific grade. You're not going to get a grade on this and a grade on that. You're not going to get 2 grades just for taking 1 test. You're just going to get 1 specific grade for what you did on that Friday assessment. That would be an example of a function. Every quiz has 1 grade. Something that's not an example of a function, if I were to split you up into groups of what sport you play, why is that not a function? Some of you played more than 1 sport. Why else? Some people don't play sports. They wouldn't have a group to go to. And so every single input needs a specific output. So if you don't play a sport, you don't have an output. Or if you play 2 sports, you have 2 outputs. And that can't be a function. Every single person can only go to 1 spot. Are we okay with this example or these definitions so far? You're allowed to say no. Okay. Another way to think about a function, when we talk about it in specifics to math, is it's like a machine. So you put something in the machine and something comes out. So functions always have a specific rule. So for example, we had those rules before. We had the sports group rule or things like that. Sometimes that rule could look like an expression or an equation. So I put an input into my function, I get an output. If I were to put 1 into this function, what would be my output? 4. I put 1 in, 1 plus 4 or 1 plus 3 is 4. 4 would be my output. If I put 17 in my function, what would I get? 20. If I put -2 into my function, what would I get? So whatever number I put in, I'm always going to get some output, right? No? Is there a number you can think of that you put in that you want to get an output?
Yeah.
What?
Negative.
You put -10 in there, what's your output?
-3, I'm at -3.
If you put -3 in there, what's your output?
Nothing.
0. That's still an output. So every single input has a specific output. What about this one? If I put 3 into this function, what output am I getting? So I put 3 in, I replace my x with 3. So what's 3 squared is 9 times 2, which gives me 18. If I put 3 in, I got 18. If I put, let's say, 5 into my function, what do I get? 50. 5 squared is 25 times 2 is 50. If I put -2 in my function, do I still get an output? So what's -2 squared? 4 times 2, 8. And it's possible for, if I put 2 into my function, 2 squared is 4 times 2, which is also 8. So it's possible to have multiple inputs go to the same output, just like you had multiple of you stand in different groups. That's okay. But as long as every single number has 1 specific output, that makes it a function. Are we okay with this still? Have you talked about this in the past?
Yeah.
Okay, that's good. Makes it easier on me. I will do one more example like this. Square root of x. If I put 4 into my function, what do I get? If I put 16 in my function, 4. The square root of 16 is 4. 2 numbers that multiply together to equal itself. If I put -9 into my function,
You get some.
Positive 3.
who has a calculator on them? Take the square root of a negative number for me. Tell me what your calculator says.
Wakanda forever. those.
Can you try it on your phone? We'll tell you something. Or does it not?
I can search up my Telegram.
What is that? Error syntax or input error, or it might say non-real solution sometimes. Are you allowed to take square roots of negative numbers? So in order for something to be a negative, or in order to take the square root, you have to think of two numbers that multiply to get to that number, right? The same number. So Destiny, you said -3. So if we multiply -3 by -3, what's that number? 9, but it's going to be a positive 9 because it's two negatives. It's impossible to get two negative numbers to multiply to get a negative. So it's impossible to take the square root of any negative number. So is this a function? Why not? -9 doesn't have an output. Any negative number doesn't have an output for this function, actually. So this is what we would consider not a function. Are we okay with that ruling?
Yeah.
Okay. So that's one way to determine functions. If you had a rule like that, just think, okay, is there any possible number I can put into this that would give me a number that doesn't have an output? That's one way to determine functions, whether something's a function or not. Another way is if we have a graph. So you may have done this last year, but we have something called the vertical line test. So this vertical line test can help us determine whether a graph of an equation or a graph of something is a function. So what the vertical line test is, it says if I have a vertical line,
That's a function.
I'm going to actually make it a vertical line.
But the basketball one is not a function.
So if I have a vertical line, if I take this vertical line and pull it across my graph, as long as I only touch my graph once, I'm a function. You remember that from last year? Good. So this is a function because no matter what, we're only touching that graph at one point. This one, though, is not a function because we're touching it up here and down here at the same time. Because your x is your input, but we have two outputs for that answer, so that cannot be a function. So that's how the vertical line test can help us. So looking at these two crazy functions, or crazy graphs, sorry, we don't know if they're functions or not. Can you determine whether they are functions?
Yeah.
What are our thoughts about the first one? No.
Function.
You draw your line where we can touch at two different points, not a function.
Oh, but the second one's a function. That one's a function.
Is that one a function?
Yeah.
So even though it is squiggling all around and all over the place, if we pull out our line, and we pull our line, we're still only touch it at one point at a time. Slowly but surely, but even though it's going up and down and all over the place, as long as we can only touch it at one point with that vertical line, it's good. So that is a function. Breeze through this.
I knew everything. I'm a math position.
Did you do math last year as well?
Yeah.
So, for those of you who might not remember, another way to determine functions is input-output maps. So we have a list of whatever the inputs are in that function. We have a list of whatever the outputs are. And then we draw a little arrow showing which input goes to which output. As long as every input has a specific output to go to, we're good. But if we run into situations where an input doesn't have any outputs, or has multiple outputs, or doesn't have an output, that's when it's not a function. So 5 is going to 2 and 9, which would no longer make this a function. It only takes one number to not have an output to throw the whole thing off. Even if all the others are fine, as long as there's a 5 in there, it's not a function. Are we okay with this? What about this first one? What was that, Briley? Why not? The 10 is going to 1 and 2, and then 20 is going to 4 and 5. Can't be a function because we have multiple outputs. What about the second one?
The 3 and C going to, like, C going to 1 and 3.
So what's our thought? Yes or no?
No.
No?
No.
So let's think back to that activity that we did. For the going to school one, was there anyone who rode a bike? Did we have multiple people riding cars? Was that still a function? So it's okay if an output doesn't have an input. The only definition of a function is that every single input has to have an output. It doesn't mean every single output has to have one. So every single input has to go to at least one spot. And if it goes to more than one spot, it's not. So that would still be considered a function, even though A is all by itself, and even though 1 and 3 are going to C, you can still consider this a function. So I honestly thought this would take us longer to talk about, but it seems like you guys.
Are we done?
I'm gonna try to think of something to do really quick.
How much is chicken?